Hi, and welcome to this section of the pre-algebra tutor. And in this section, we're going to wrap up pre-algebra with sort of the pinnacle of everything we've been building up until now, and that is the idea of solving an equation. So specifically in this section, we're going to be solving single-step equations. That means these equations, I don't want to call them simple because, everything when you first learn it is a little bit difficult until you really understand it. But they're only going to involve one, maybe two very simple steps. Most of the time one step to solve. But that doesn't mean that you can just relax and crack your knuckles. You really have to understand what you're doing here, and that's what we're going to do. We're going to teach you that. So what is an equation? Basically, an equation has an equal sign in it. When you have some algebra expression on the left-hand side with a variable, and you've got some stuff on the right-hand side, maybe some numbers, maybe some more variables, then you're said to have an equation. So what you have is some unknown value of the variable, x or a or b or whatever it is, and your job is to try to solve for that value. So you don't know what it is. It could be the temperature in this room. Maybe I have something that equates the temperature in this room, or the speed of a baseball. Maybe I want to solve for that speed. How do I manipulate this guy to solve for the thing I'm trying to solve for, the variable? And so what you need to realize is you have complete latitude to do everything you want within reason. So there's three things you need to know to be able to ace this entire section. The first thing is the goal of solving an equation is to isolate the variable that you want on one side of the equal sign by itself. Everything else you want to push to the other side of the equal sign. So in the end you want to get x is equal to 4 or x is equal to 5. So the way you do that is you move x to one side, you move everything else to the other side. Second thing is, in order to do that, you can do anything you want to both sides of that equation as long as you do it to both sides. You can add or subtract numbers to both sides of that equation as long as you do it to both sides, like seesaw. You can multiply, divide both sides of that equation as long as you do the same thing to both sides. And the final thing you need to know is that in order to pull it off, sort of the final piece of the puzzle, addition is the opposite of subtraction, and multiplication is the opposite of division. So depending on what you have, if you have an addition going on here, you might want to get rid of it. So you subtract it to get rid of it and push it to the other side. If you have multiplication going on, you might do some division to get that guy, get rid of it, and isolate the variable like you want. So you can talk about this stuff all day. The easiest thing to do is just start working some problems. So let's do that right now. The easiest equation you could probably have would be something like this. X minus 3 is equal to 9. How would you solve this equation? Remember, the goal is to get x by itself. You want him by himself. The only thing standing in your way is you have this minus 3 here. So what you want to do is you want to, because you have subtraction, addition is the opposite of subtraction, so you want to add 3 to both sides. The only thing different between this line and the previous line is I've added 3 here and I've added 3 here. The equation is the same, but I've added 3 to both sides, so I haven't really changed the equation, although I've changed the way it looks, because negative 3 plus 3 is 0, so on the left I'll have x, on the right I will have 12, and that would be the answer. You have solved this equation. X is equal to 12. This could be the speed of a baseball. This could be, how high up you must go in an elevator for something. This could be the temperature in a room, but you've solved for it by using the rules of algebra. Now, you can always check your work with equations, because you get an answer, you can plug that answer right back into the equation. 12 is x, so we say 12 minus 3 is 9. 9 equals 9. That's good, that's our answer. So with simple equations like this, you might be able to guess the answer. You might be able to guess that 12 goes here. But don't guess. That doesn't do you any favors. If you start guessing is the wrong word, you might say, well, I know how to do that in my head, but that doesn't do you any favors, because I guarantee you I'll get to an equation here in a minute you won't be able to do in your head. So if you start doing things in your head all the time, then you won't get any practice with really how you're supposed to think, which is logically moving everything. In this case, we move this negative 3 over to the other side. Let's do another similar one, just to get some practice. What if I have n plus 6 is equal to 12? I have the same kind of thing. I've got n that I want to get by himself, but I've got the 6 in the way. So I rewrite the equation, except I subtract 6 from this side, and I subtract 6 from the other side. So this equation is the same as this one. The only reason I'm subtracting it like this is because this is going to make 0. So on the left-hand side, I'm going to have n is equal to 12 minus 6 is 6. And that is the answer. I've isolated the variable n. That's what I get on the right-hand side. Now I can check my work by sticking it in here. 6 plus 6 is 12, so I've got the right answer. And again, you could probably guess this, but that isn't doing you any favors if you just jump ahead like that. What if I have y minus 4 is equal to negative 2? I want to isolate y. So in order to get rid of this 4, I have to do the opposite. So I'm going to add 4. Y minus 4 plus 4 is equal to negative 2 plus 4. This equation is exactly the same as this one. I'm just adding 4 to both sides because I'm going to make this go to 0. So I'm going to have y by himself is equal to negative 2 plus 4 is going to give me positive 2. And that is the value of the answer. And you could again put it in here. 2 minus 4 gives me negative 2. So you can check your work with every equation that you really do. So let's try a different kind. Then we've done addition and subtraction. What if we have 3 times x is equal to 9? Much like we've had addition and subtraction doing the opposite, here we have 3 times x. They're multiplied. So in order to get x by himself, we have to do the opposite. We have to do division. So let me rewrite the equation. I can divide both sides of this equation by 3. Why do I do that? It's because this, when I do it, the 3's are going to cancel out. So I'm going to have x is equal to 9 divided by 3 gives me 3. That is the answer. And you can check it by putting x back in here. 3 times 3 is 9. So you really just need to look and do the opposite of whatever it is you're trying, whatever stands in your way, so to speak. So another example, if you had 6 times n is equal to 12, this is multiplication. The only way to get n by himself is to do the opposite, to do division. So I'm going to divide by 6. Then I'm going to have these 6's cancel like that. So I'm going to have n is equal to 12 divided by 6, which gives me 2. And that's why we do the opposite, by the way. That's the only reason we do the opposite. It's because we're trying to isolate the variable. Now let's do another slightly different one. Let's say I have x divided by 3 is equal to 9. And again, I want to get x by himself, but here I've got division going on. The opposite of division is multiplication. So I can, again, work with this guy. Let's do x over 3 is equal to 9. But I can multiply both sides of this guy. I can multiply by 3, and I can multiply by 3. I can do anything I want to both sides of an equation as long as I do it to both sides. Why do I do that? Because when I multiply like this 3 is going to cancel with this 3, leaving only x is equal to 9 times 3 is 27. And that's the answer. And to check it, you put it back in here. 27 over 3 does equal 9. So we're really just going to continue building on this. Let's do n over 4 is equal to 12. How would you solve that? Well, you've got division going on. So you want to do multiplication to get n by itself. So let's say we have n over 4 is equal to 12. So I'm going to multiply this equation by what? By 4, so that I can cancel these 4's, leaving n is equal to 12 times 4 is 48. And that is the answer. And if you want to know that it's the answer, put 48 divided by 4 does equal 12. So you have correctly solved for that equation. What if I had 4y is equal to negative 2? Well, I've got multiplication going on here. So in order to get rid of it, I need to do the opposite. I need to do division. Divide by 4 on both sides. So negative 2 divided by 4. Right? The reason I do it is because the 4's cancel, leaving only y is equal to negative 2 divided by 4 is going to be negative 1/2. Y is equal to negative 1/2. So from here on out, since we're doing single-step equations for the most part, we're really going to be really having the same thing. We're just going to do some different problems to give you a little bit of experience. What if I have something like negative x is equal to 1? You might say, how do I do that? Well, don't forget, this is like negative 1 times x. So if I want to, I can have negative x is equal to 1. I can divide both sides of this guy by negative 1. So I'm going to have the negatives cancel. Negative times negative 1 divided by negative 1 cancel. And so in the end, I'm going to have x is equal to, what's this? 1 divided by negative 1 gives me negative 1. And that's going to be the answer there. Okay. What if I have, let's say I have negative 4 is equal to negative x. Now I have the same sort of thing going on. I can divide both sides of this equation by negative 1 because that's the only thing in front of the x there. So what's going to happen here, the negatives are going to cancel. And so over here, I'm going to have negative 4 divided by negative 1 gives me positive 4 is equal to x. Now don't worry if the x is on one side of the equal sign. Remember, it doesn't really matter. As long as you put x on one side and everything else on the other side, you know the answer. 4 is equal to x is equal to 4, however you want to write it, you can plug it back into the equation and make sure that you got the right answer. If you put 4 in here, you get negative 4, which matches what you had on the other side. All right, now let's do negative 3 minus x is equal to 9. Now this is a little bit more complicated than what we've had before, but still we want to isolate x, so let's work on getting him by himself one step at a time. Let's take this negative 3 and move it over here. So the way we do that is we're going to have negative 3, and I'm going to add 3 to this side of the equation because I'm doing the opposite of subtraction. I'm doing addition. Minus x is equal to 9, and I'm going to add 3 to this side of the equation. So I've got addition of 3. Now this goes away, so I'm going to have negative x on the left is equal to 9 plus 3 is 12. Now that's not quite the answer because I still have a negative sign here. I need to get x totally by himself. So what I'm going to do is divide this by negative 1, like this. And that's going to cancel. The negatives are going to cancel, and so I'm going to have x is equal to 12 divided by negative 1 is negative 12. All right, now let's say we have negative 12 equals negative 2 minus x. We have the same thing we want to do, no different. We want to get x by himself, so let's work on getting this negative 2 over here. So we're going to add 2 to both sides because we're going to do the opposite. So we'll have negative 12, we're going to add 2, is equal to negative 2, I'm going to add 2 to this side, minus x. Just add 2 to both sides. That's going to get rid of this, but on the left-hand side we'll have negative 10 is equal to, over here we'll have negative x. Right? And so we're not quite done yet though. We have to divide both sides by negative 1 so we can get rid of this negative sign. So what we'll have over here, negative 10 divided by negative 1 will give us positive 10 is equal to x, and x will be equal to 10, and that's the answer. And you can see that it's the answer because if you put 10 in here, then you have negative 2 minus 10. That does equal negative 12. So you've done the right thing. Now what if you have 2 is equal to negative x over 12? So you want to get x by itself. What you need to do is multiply because you've got division going on here. So you have 2. Let's multiply by negative 12. Because on this side I'm going to have negative x over 12, I'm going to multiply by negative 12. The reason I'm multiplying by negative 12 is because like I told you, this negative sign can float. It can go up or it can go down. So I'm going to sort of stick it down there so I can cancel the negative 12 with the negative 12. So this times this is going to give me negative 24 is equal to x. And that's the answer. X is equal to negative 24. And if you put it in here, negative 24, 24 divided by 12 is 2. Negative divided by negative is going to give me my positive, and that's the answer. So I'm just going to do a few more of these. None are really any more difficult than anything else, but let's do one with fractions, just to kind of give you an idea that there's not really a big deal. X plus 1/2 is equal to 4. This is the same thing. It's just that you have a fraction involved. We need to get this fraction over here, so we're going to subtract it. X plus 1/2, and I'm going to have minus 1/2, is equal to 4 minus 1/2. Just subtracting 1/2 from both sides. So this disappears. So I'm going to have x is equal to, what's 4 minus 1/2? Well, if you don't know off the top of your head, you can say 4 over 1 minus 1/2. And you can deal with the fraction business here by saying 4 over 1, multiply this guy by 2 on the top and bottom to give me a common denominator with what I have over here. So what I'll have over here, 4 times 2 is 8 over 2 minus 1 over 2. And so what I'll have here 8 minus 1 is 7 over 2, 7 halves. Now this is improper, so I can divide this in. It will go 3 times. Well, that's going to give me 6, remainder of 1, write it over 2, like this. So 3 and 1 half. Now, a lot of you might have been able to look at 4 minus a half and figured out that it was 3 1/2, and that's okay. But fraction-wise, this is how we're going to tackle the problem. So if there's a fraction in your problem, you're really not going to do anything different or special or worry about it. If there's a decimal in your problem, you're certainly not going to worry about it. You're just going to need to be good at fractions, which is sort of one thing I've been saying since the very, very beginning. What if you have y minus 2/3 is equal to 2/3? How do you handle that? Well, the same way. You're trying to get y by itself. So we're going to add 2/3 to both sides because we're going to basically add the opposite of what we have. 2/3 is equal to 2/3 plus 2/3. So this goes away to 0, so we're left with y. Here we have a common denominator, 3. We add the tops. 2 plus 2 is 4. So we have an improper fraction. So we're going to say y is equal to, how many times can it go in? It can go 1 time, remainder of 1 over 3. So 1 and 1/3. So if you have fractions, just take it one step at a time. And, we'll go ahead and do one more nice juicy one with fractions again and give you a little bit of practice. What if we had a plus 1 and 2/5 is equal to 4/5? Okay, probably the easiest way to handle this is to go ahead and take this guy and subtract it and get a by itself. So let's do that right now. We'll have a plus 1 and 2/5 minus 1 and 2/5 is equal to 4/5 minus 1 and 2/5. So this is going to go away, so you're going to have a is equal to. Now, in order to actually do the subtraction, it's going to be a little bit easier if we just write this as 4/5 minus, let's convert this to improper. 5 times 1 is 5, plus 2 is 7/5. Now it's much easier to sort of deal with. What we have is a common denominator of 5, and on the top we just do the subtraction. 4 minus 7 is going to give us negative 3. So a will be equal to negative 3/5. Negative 3/5. And that's the answer. And if you take this, if you were to take this, negative 3/5, and put it back in here and add it, you would find that this is right. Now that's a little bit more cumbersome to do because when you're adding fractions, it's not something you're going to be able to do off the top of your head. You'll need to get some paper out and work on it. But the same principle does apply. Let's do one final one, just to give you one more example involving fractions. What if you have negative 2x over 5 is equal to 3/4? Now, we want to get x by itself. We want to get x by itself. But we have a problem because it's got a 2 in the top, negative 2 in the top, it's got a 5 in the bottom. There's a few different ways to explain how to do this, but when you think about it, if I multiply this side by 5 halves, better yet, let's make it negative 5 halves, then I'm going to accomplish what I'm trying to accomplish. If I have 3/4, and if I multiply this by negative 5 halves, again, I'm multiplying by exactly the same thing on both sides. Now, why did I do that? Because on the left-hand side, when I do that, the 2 is going to cancel with the 2, the 5 is going to cancel with the 5, the negative is going to multiply by the negative to give me positive, so I'm going to end up with x right there. And I'm going to isolate it totally by itself. On the right-hand side, I just do this multiplication. 3 times 5 is 15, but don't forget the negative. 4 times 2 is 8. All right? Now, this is improper, so I can simplify that by saying, how many times can 8 go into this? It can only go 1 time. Don't forget your negative. What's the remainder left over? You're going to have 7, and you always write it over 8. So you have 1 and 7/8, negative 1 and 7/8. So we have covered a very important topic in this section. We've started to solve simple equations. I say simple just because they're one-step equations. Now, in future courses, when you go on and study more algebra, your equations will get a little bit more complicated. You'll have different techniques of isolating x by itself and all that stuff, but fundamentally it's the same thing. Your goal is, it's like a shell game. Your goal is, x is over here wrapped up in some other stuff. Your goal is to bust it apart, move x over on one side, move everything else to the other side, and then you know what x is equal to. X could be the speed of an airplane. X could be the position of a spaceship. X could be anything. Equations can represent anything in the real world. Can represent, you know, how much I'm pushing on the wall or something like that. So knowing how to manipulate them, it really opens up the world for you to be able to study all types of really cool things like physics and motion and engineering and other things, because you're always solving for an unknown quantity. And so here we've used the rules that we've laid out before you to show you how to solve for those unknown quantities. And I hope I've made it clear for you. When you get to more complicated equations, it's going to be the same thing. You're just going to have to do more than one step to get where you're trying to go. Here, this is the end of the pre-algebra tutor. We've taken you from the beginning, 1 plus 1, talked about negative numbers, talked about fractions, talked about expressions, simplifying expressions, and now solving elementary equations. When you're done with this course, you should go into my Algebra 1 DVD, which is called Fractions Through Algebra, and then that way you'll pick up where we leave off here. You'll get a little bit of a review. You'll pick up where we leave off. You'll go into more complicated equations, more complicated expressions, but it will seamlessly follow. I hope you've enjoyed the course. I hope you've learned something from it. Practice your problems. Work these problems again if you need to. It can surely help you, even if you've already seen them once, to work them out again. I encourage you to do that. Practice your problems, get your confidence up. I have no doubt that if you've come this far, you understand this, everything beyond will be so much easier, and you'll get so much more benefit and usefulness out of it. I'm Jason. Have a great day.